Hello guys, I'm going to use this video to simplify some exponential expressions, show you how to do. Okay, so one thing you can do here is taking care of this part first because of the negative 5 as the exponent you have outside here. So this can be written as 1 over 2x to the power of 5. As you can see, I changed the sign to a positive and I flipped this because it's 2x, just like you have 2x over 1, so I can, like 2x over 1, so I can flip it, put the 1 over 2x now, as you see it here. Okay, so then the other side, the other part, 2x to the negative 3 y z to the negative 6 stays the way it is. Okay, then we can keep going here. I'll probably have to erase this part so we can have enough room for this. So so we keep going, as I said, 2x to the negative 3 y z to the negative 6. Then here, this is 1 to the 5th power, which is 1, and 2x to the 5th power. Now 2x times 2x times 2x, 5 times, right? So 2 times 2 is 4 times 2, 8 times 2, 16 times 2, which is 5 times, would be 32. Okay, and 32 and x to the 5th. Okay, all right. So now once you do this, we can actually multiply now because, you know, the exponent's not here anymore. So if we multiply this, it's as if we have this over 1. So 1 on top here times the top here, numerators together, will give you 2x to the negative 3 y z to the negative 6, okay, over 1 times this part here is just 32x to the 5th, okay. Now, just we're dividing here, so remember what to do with the exponent. Now 2 goes into 32, 2 goes into 32 16 times, okay. Therefore, we're gonna have here on the bottom 16, and the 2 on top is gone. Now x to the negative third minus, because we have to subtract here the exponents, I'm saying. So I'll put x. If it's division, you know, you have to subtract the exponent. So negative 3. I'll put minus 5 because you have to, I'm moving it up, so I change the sign. It's as if, what I'm saying here is this, guys. If you have a to the m over a, or whatever it is, to the a to the n, whatever the exponent I'm saying, this will be the same thing as a to the m minus n. So that's what I'm using to do this right here, on top here. All right, so now I have y by itself and z to the negative 6, the way it is, okay? So after this, what you do, you keep going, so keep simplifying. So I have x to the negative 8, okay, y z to the negative 6 over 16. Now this, guys, is, now remember, you cannot give your answer with negative exponents, okay? So in order for you to change exponents to form being a negative to a positive, you either move them up or down. Now in this case here, these were in the numerators, so for me to change this, to change their signs, I just need to move them to the bottom. So I'll have now 16 x to the 8 and z to the 6, okay? The y stays here because the power was positive 1, so it's not negative. So the answer, y over 16x to the 8, z to the 6, okay? So this is how you do this one right here. Now let's try the other one I said, the other one I was talking about. So let's do it together. Number 2, which I erased, okay? So let's do number 2. Number 2 is, for number 2, you have what I put was x cubed y to the fourth and z to the fifth, okay, and x to the negative 3, y to the negative 4, z to the negative 5, okay. That's what we got, and negative 2 right here. Okay, so first thing we can do here, we can do what's inside the parenthesis first, or however you want to do it, but this is easier. So I'll just do what's inside parenthesis first. So I'll have x to the negative 3, positive 3 first, to the positive 3 minus a negative 3, because I'm subtracting what I have, the exponent on top, with the one on the bottom, okay? Then y to the fourth minus negative 4, then z to the fifth minus negative 5, okay? And this to the power of negative 2. So then I have x to the, this becomes a positive here, positive. So we add 3 plus 3 is 6. So x to the 6, y to the 8, because I'm adding, and z to the 10, okay? Again to the power of negative 2. Now, from here, guys, you can use the exponent now. You know, you have exponents inside, one outside, so you gotta multiply them. So you have, let me erase this. So you have now x to the 6 times negative 2 is negative 12. Y to the negative 16, that's 8 times negative 2. And z to the negative 20, that's 10 times negative 2. So again, remembering what I said, you cannot leave them as negative exponents, so you have to flip this as if you had a 1 on the bottom. So now it's on top, okay? So now it's x to the 12, because you move these to the bottom, to the denominator, so they could be positive, okay? Then z to the 20. That's it. So 1 over x to the 12, y to the 16, z to the 20, okay? Not bad at all, okay? Not bad at all. Okay, so now let's try this one here. All right, now in this case here, guys, we can go ahead and use the exponent. So if I do that, I'll have let me actually put it here so I can have more space. I have 2 to the negative 1 to the negative 2, that's 2 to the positive 2, because negative 1 times negative 2 is positive 2. Then x to the negative 1 negative 2 times negative 2 is positive 4, x to the positive 4, and y to the positive 2. I do the same thing here. This is 2 to the negative 2, because it's as if you have a 1 here times negative 2 is negative 2. Then x to the positive 8, okay? And y to the negative 6. And we keep going. We have, now this is 16 x to the negative 3 times y to the positive 3 to the 0. Now anything to the power of 0 but 0, by the way, 0 to the power of 0 is indeterminate, but this to the power of 0 is 1, okay? So 1 here. Then the bottom part, we do the same thing. We have 2 to the power of 2, x to the power of negative 3 times 2, negative 6, y to the power of negative 5 times 2, negative 10, okay? Then we keep going, all right? We keep going. We have, now on top here, I can choose to multiply like bases. So 2 times 2 here, 2 to the second times 2 to the negative 2 would be, remember I'm multiplying, would be 2 to the 2 plus negative 2. When multiplying same bases with different or same exponents, you add the exponents. So it's then 2 to the 2 plus negative 2, and x to the 4 here plus the 8, and y to the 2 plus the negative 6 over 2 to the second here. I'll leave it as 2 to the second for now. Doesn't really matter. And x to the negative 6, y to the negative 10. Okay. And we keep going, right? Let's keep going. We have now 2 to the 0 here, okay? Because that's 2 minus 2, which is 0. So 2 to the 0 is 1 times x to the 12, and y to the 2 minus 6 is negative 4, y to the negative 4, okay? And the bottom part, again, is 2, we can put 4 here, by the way, x to the negative 6, y to the negative 10. All right, so now we keep moving. We have now 1 times this is the same thing. So I'm just going to try to do whatever I have to do here. I'll put 4 here. And for exponents, I'm going to just do what I have to do, 1 on top, 1 on the bottom. So I'm going to subtract. So it's x to the 12 minus the negative 6 right here, because it's a division. So you subtract. Just like in multiplication here, you add. For divisions, you subtract. So, and y to the negative 4 minus negative 10, okay? Then for this, we just keep going, okay? Have enough space here. So it's x, the top, x to the 12, this is a plus sign here now. So 12 plus 6, which is 18, so x to the 18, y to the negative 4 plus 10, okay, which is 6, positive, I'm saying. So 6, then 4, okay? So this is what you have when you subtract the exponents, when you simplify this, I'm saying. So final answer, x to the 18, y to the 6 over 4. This is your final answer. So this is how you simplify something like this, guys, okay? And remember, all I'm using here are just the properties of exponents, okay? So if you have what I showed you before, so if it's a to the m times a to the n, then you have a to the m plus n. If it's a to the m over a to the n, it's a to the m minus n. So that's all I was using here, okay? So that's all you get. This is how you simplify exponential expressions. Thank you.